Assalamu alaikum. My name is Hira Zamir. I'm a student of MS Chemistry in University of Management and Technology. I'm going to present about my topic under the supervision of Dr. Hammad Majeed. My topic is monolithic reactors. Intro. The word monolithic is originated from the Greek language which means single stone. In catalytic chemical engineering, a monolith is defined as a single block of catalyst that contain material through which reactants can be converted into the products. It has such macroscopic dimensions that one or a few monoliths can completely fill the catalytic receptor space. Catalyst material is made of the tiny particles or the pellets. In this reactor, catalyst and the reactors are integrated into the single piece in form of honeycomb-like structure that contain the structure of interconnected channels. This is somehow the monolithic reactor look likes. In the inner side, they are consist of the microchannels, which give the overall presentation of honeycomb-like structures. Key feature of the monolithic reactors. First of all, it has a simplified maintenance which make it more easy to use, flexible to operate. Single piece design reduces the number of components and hence very easy to maintain. Improve heat transfer. These provide better heat transfer and thermal efficiency and control over the heat, yet provide safety. Because there are so many surface channels, they provide high surface to volume ratio. Surface area is very high in this, so heat transfer is very efficient. High efficiency. Monolithic reactors offer high precision combined with the high efficiency that improve the reaction rate. Compact size. It has a compact size compared to the most other structured reactors. They are very cost effective and they can be obtained in a large variety of materials. Low pressure drop. Due to the absence of spaces between catalyst particles, reduces the pressure drop which is important in high pressure processes. It improved the selectivity. These reactors can be designed with precise control over the flow of reactants and products that enhance selectivity in the chemical reaction. Now let's just talk about the structure of the monolithic reactor. It contains the monolithic substrate, typically porous and high surface area material such as ceramics or metal that is used to make core of the substrate, which is shaped into the like honeycomb structure. Coating on catalyst, then monolithic substrate is coated with a catalyst material which in form of the thin layer or the wash coat that is present onto the porous wall of the substrate. This catalyst coating is specific according to the chemical reaction that is desired. Inlet and outlet ports. Reaction contains inlet and outlet ports for the introduction of the reactant and the removal of products. These openings are located opposite end of the substrate and designed to promote even flow distribution and reduces the pressure drop. Geometry is very important for the formation of the monolithic reactors. Channels are present within the substrate can vary according to the specific reactions. Channel shape and dimensions can be changed to optimize heat and mass transfer and reactant distribution. Thermal control. These contain thermal control system like cooling jet or heating elements to attain the desired reactions. That is our monolithic reactor in which the liquid fed is present which fed the material into the reactant, that is monolithic reactor, and the gas is also fed. It contains the gas recirculations, gas liquid separate hoga, and then we can obtain our product, which is pumped into the heat exchange. Same way, the coolant is used, his heating exchanger is used. Our purge or the raw material is entered into the monolithic reactant, and then it goes through the various processes and we can obtain our product. This structure is designed to provide efficient contact between reactant and catalyst coated surface to give desired chemical reaction with low pressure drop. This is rarely used in automatic emission control and petrochemical industries where high mass and heat transfer specific surface area is very crucial. In this, the inner side is the honeycomb-like structure is monolithic threaded with optical fibers. We inlet is used to send our carbon dioxide and water, that is the gaseous form, and outlet we obtain the methane and ketone. This is the cross section area. It contains the coated monolithic channels and inner side is reflected rays and non-coated sidelight emitting optical fibers that is used for the chemical reactions. One of the major application or the major uses of the monolithic reactor is flow phenomena and laminar flow through streamlined and sharp edged monolithic structures. The main advantage of monoliths are large specific surface and low flow resistance. The first monoliths were made of ceramics, and soon after the other materials like graphite, alumina is used. In the developed laminar flow, the streamline are parallel throughout the channel, and the heat transport takes place by the conduction, that is the diffusion. The process efficiency in the catalytic reactor cannot be greater than the mass transport to the catalyst. Only those molecules may react which has reached the catalytic surface. Streamlined structures would be a development of the short channel ones, maintaining their ability to regulate heat and mass transport coefficients. The main change was the shape of the channel wall. Streamlined structures would be a development of short channel one that maintaining the ability to regulate heat and mass transport coefficients. The main change was the shape of the channel wall. Its longitudinal section was similar to the airfoil profile. Airfoil profile is used that was expected the streamlined structure would enable the elimination of the unfavorable inlet velocities, thus improving the efficiency of heat and mass transport. Extensive stimulation of fluid flow and heat transfer phenomena was performed for the design geometry of the streamlined structures using CFD. This show how the theoretical heat and mass transfer distribution occurs, but the real heat and mass transfer distribution is different, which is less more efficient and less disturbing because we're using the laminar flow mechanism. The other application of the monolithic reactors is it is used in automobile exhaust treatments, diesel catalysts for the treatment of liquid particulates and gaseous carbon dioxide and hydrocarbons. Ozone abandonment in the aircraft, natural gas engines, that is, the ozone destructions on automobile radiators, which produces the carbon monoxide and hydrocarbon oxidation in the small engines, selective reduction of nitrox, destruction of the volatile organic compound from the chemical plant, domestic sources and restaurants, catalytical combustions. As emerging application, hydrogen generation for the fuel cell, steam reforming of the hydrocarbons, water gas shift catalyst, and oxidation of the carbon monoxide at lower pressure. Simply, it is very friendly reactor that is used for the mm, environment to make the environment clean, like from the automobiles, from the industries, from the domestic waste. There is a lot of hydrocarbons, carbon monoxides, and nitrox, which affect the ozone layer, which cause the greenhouse effect, which affect the temperature of the world, that causing many problems and diseases and issues. These all can be treated from the monolithic reactors. All these hydrocarbons, carbon monoxide and nitrox are led from the inlet, sent into the monolithic wall, and in which the catalyst wash coat is present, where the reaction takes place, and it simply convert our reactant into the carbon dioxide, nitrogen dioxide, and and the water, which is environment friendly. This is how we can reduce the pressure, the waste, biological waste, which is present in a very large amount, into the very less toxic substrate by using a simple monolithic reactors. This is the best usage of the monolithic reactors. References. Thank you so much.